So a little bit of attention from everybody. I want to cover a bit this last session that I think is quite important to accomplish all the different tasks that we have been seeing in geocomputation. Okay, so is the use of GRASS inside to the HPC. So how many of you have been using GRASS in general? Okay, 3, 4, 5, 6. Okay. GRASS is another software for doing geoprocessing. Is super powerful. It has a lot of modules, also for hydrology, for forestry fragmentation, cost path analysis, and so on. There is one caveat that is very stubborn in terms of the folder structure. So it's not really easy doable by pointing to one file directly. So you have to kind of build up this GRASS structure in order to be able to use GRASS, okay? So I'm not going to go deep in all this explanation about GRASS work, but we will see how to use it inside to the HPC with the basic tools and scripting that we saw, but with some caveat. Okay, so if you click over here, still in the spatial ecology page, scrolling down in the HPC, you have the web page over here, use of GRASS for HPC. Okay, so I'm setting up a scripting procedure that does something very simple, importing the dam and calculate the slope. Okay, these one are the typical SLARM setting that we saw so far. There is no any kind of parallelization, but later on you can do with importing the other setting. Over here is where there is the tricks. Here, of course, you load the module GRASS. You define the variable where you, the directory where you want to import it. And over here is the GRASS session that we are going to use it and running in this particular scripting procedure. So before to run, you cannot point directly GRASS to do something native like we were doing with GDAL. You need to build up the structure around it. This structure around it, this folder structure, need to be done with one specific file that is going to be your master file, call it, where it has to have correct projection information, really precise extent, and really well-defined pixel resolution. So all these 3 parameters need to be well set. At this point, admit, can anyone admit, and click anyway. So at this point, when you setting up your master file, you can create one specific, is going to create automatically a temporary location and map set. So this folder structure is going to be somewhere in the TMP that you, frankly speaking, you don't need to know, okay? There is one little tricks that need to be done inside GRASS when using GRASS inside to the HPC, especially if you're running many jobs, is to try to use as much as possible folder that are mounted directly. They belong to the node. In this way, you don't create so much I/O through the hard disk. Okay, and then only when the job is done, you transfer your final TIFF to the hard disk. So what I'm going to do I'm going to transfer the TIFF to the TMP, and the TMP is the TMP of the node. Okay, so when is going to be there, my file is going to be read directly inside to the node and not from the hard disk. Okay, so at this point, this line is going to create this temporary location. Our external is going to read, actually even not to read, but just point a file that is sitting in my TMP, so it's not anymore in the hard disk. And then whatever you do inside here is not going to overload and transfer to the hard disk, but is going to stay where? Inside to the TMP. Okay? When the slope has been calculated, because I calculated slope, only then you can transfer back to your destination that is sitting in the hard disk or in your home. Okay? So this is the tricky part, that you have to transfer your file directly to the TMP of the node. Of course, if you are running one job, nothing happened. But if you start, and you can even, this one can even sitting in your hard disk on your home. But if you starting to use intensively, this kind of operation can really slow down the full cluster, because Grass has very high I/O quantity and loading, so it's really can slow down the cluster. Okay. Anyone that was using Grass was already using this TMP folder, because you can use it also in your machine, this technique. 1, 2, okay. So now you should know how to use directly how to build up this Grass structure with this line, and then how to import a file and how to run the slope and aspect. Of course, now we are running one job, but if you can imagine, if you have 10 files of this one with a for loop, you can run it, for in parallelization and so on. And over there is where you overload the I/O on the cluster. Okay, cool. There is something also a bit more advanced, and let's see before going in this little trick, that let's see how many people knows. If I have a sequence, just this number is creating a sequence. If I do like this, it's creating a long sequence. So if I create this long sequence of file and I save it to a file, and I save it to a file, and I save it to a file to the TMP, and then to a folder that is called /dev/shm. Anyone knows why this one is taking less time? Anyone? That one? Sorry. That one is a folder that is sitting directly inside to the RAM of the computer. Okay. So this one you can see over here that the /dev/sh is the so-called temporary file system, that is nothing else than a folder sitting directly into the RAM. Okay. So if you if you do htop, as you can see, I'm using 31 giga RAM. Let's see, that file should be quite big. Now, if I cancel that file, actually, let me see how big it is. Okay, it was 1 giga, so I don't know if I will see, but should be drop. Now we go back. So my giga are dropping down to 12, okay? So what does mean? That we are writing a file inside to the RAM directly. And of course, as you can see, we are saving time, okay? Almost one minute different, 1 second different. And if it's a big file, you can save it more time. So can I use this folder inside to the cluster? Yes, each node has its own /dev/hm. Okay. And of course, if you are saving 10 files, rather than save it back to the hard disk, and you just need the 11, for example, save it inside to the /dev/hm, and then saving just the last file back to the hard disk. You are saving a lot of time, but you are using the RAM. Okay, so you have to consider it when you are requesting the RAM to the memory allocation and so on. Okay, keep in mind this. So not only the RAM for processing the file, but also the RAM to let the file sit inside to the RAM. Okay, this one is a very nice tricks that you can speed up your computation like crazy. It's really, especially maybe Raymond, I don't know if you know, because it's depending how the cluster is done. Because now if you have really fast, super fast connection, maybe you don't see difference. But if there are different kind of file system and so on, you can really see big difference. Okay, so we are going to use this folder, the /dev, for mounting, not mounting, but creating our grass structure inside to that one. So, and this is going to be done perfect the same over here, but rather than using the TMP that has been predefined, I'm going to use, first of all, copy my file in my RAM, that is this folder. So now the file is sitting there, and I'm also building my grass location inside to the RAM, okay? And then it's pretty the same. I'm loading the file from the the file that is sitting in the RAM. I do my computation for the slope, and I pull out my computation out into the hard disk. You have to keep in mind that when you finish this operation, you need to remove, okay? You need to remove the folder, the location, the folder structure of grass, and also the file that is sitting in the RAM, okay? Here I use this particular symbol, and anyone know if I do echo $, okay, I get the IP, the ID of my process, not the ID of the job, but the ID of the process. That is quite unique number. So anyone, why I'm using over here this kind of stuff? Can anyone guess it? Here, here, and here. I'm creating a folder with a unique ID. Why? Huh? No, I don't override previous one, but because it can happen that my job enter in the same node. If I have two jobs, by any chance can enter into the same node, and over there I will have the same folder with the same GrassDB folder. Okay, so you have to always think where your job can happen going in each single node. Could be that you launch many jobs, but all of them they fell inside to the same node. So this /dev is unique to the node, but can happen that two jobs are going to the same node. Okay, so you need to specify a unique folder name to yes, to be unique when you run a new job, when another job is entering the same node, okay? So try to pay attention. That's something that also you need to be very carefully, is to remove whatever you left in the RAM, because if not, it's sitting there, okay? So when it's going to re-empty, when Raymond is going to call you, or when they are shutting down the full system, okay? Here, they're quite lucky. You will be lucky in the sense that they're shutting down the full system once a week, so everything will be clean, okay? Or if not, if you are really like to this kind of computation, you need to put over here an if condition that if you find my file, the old one, like 1 week ago or 3 days ago, you need to clean it. You do an if condition to clean always your TMP and your /dev, okay? So it's something very important for Grass, because if not, you create this IO that can be really massive and slow down the full computation. I get called by the NASA HPC once because I was doing this, I didn't know. And then I figured out this technique to do it, okay? So pay attention, yeah, they called me directly at the phone. So pay attention, that can be tricky to do this kind of operation, okay? Okay, perfect. And of course, all this stuff can be combined with the previous HPC job array. Now this is just a single job, but then you can do the Xarg and multi-core operation and so on. Something also, there are just a few command before. There are a few command. Yeah, I didn't insert over here. Ah, no, I inserted. Look, there are few command in Grass that you can specify the number of processor. Not all command. There is a small minority, but they are growing. And of course, these two number of processor need to be set in the same way over here. And as you can see, I didn't do it. So over here is still using one processor. So you should put two here, and two also here. And the same for the memory. The memory that you are going to allocate for this process need to be, for example, 7,000. You need to be sure that your file plus this one plus something else is not going over past the 8,000. Okay, so these are the requirement of this kind of scripting procedure. So Grass is very powerful. He has a lot of tools. He has all the tools that you can do it in GDAL and PK tools. What I suggest always, and what I'm doing also, I do all the pre-processing inside with GDAL and PK tools. And when my file are ready to enter in Grass or even in Python, then I use Grass for something particular, even the slope, because the slope in GDAL is not, especially if you use in big tiles, global level, is not correct. So you have to do it directly in Grass that is taking care of lat long transformation for south to north, okay? So try to use as much as possible GDAL and PK tools for pre-processing, and when your data are really well scaled, organize it, you enter in Grass for other processing or inside Python for modeling and so on. Okay. Any questions? Somebody, Lucy was trying to use these tools, so now you have a good starting. And probably some from the online people.
The number of processor here is 2, no? And we have also to put it in the starting line because now it's 1.
Yeah, perfect. Yeah, please modify something that I figured out this morning. This option was that has the option to have the number of processors also here. So you need to do it here and also here. And the memory, once again, the memory should be including the memory for the computation, the memory for sitting this file, plus a bit more. So you could ask like 8,000 or 10,000. Now I'm overshooting because this file is very small. It's nothing too crazy about. Okay, please.
Yeah, I have a question
Thank you.
for the R external, and usually I use R in GDL or so.
Perfect.
And if I use R in GDL, I would not have to copy the TIFF in the temp folder because then it's already in the Grass location. And
Yes, you did
not
correct.
as a TIFF, but as fcell, I guess.
Yeah, you did.
And
Bravo,
that
very good.
also lies in the temp folder, right? So then.
Yeah, both are valid. So they are externally just a link to this file. Okay, is not imported yet in Grass. Okay, so it's going to be read whenever you launch this. Okay, so both are valid in that case because you are going to transfer only once, and is going to be pretty the same. I use more R external because I don't have a kind of data duplication. But then in that case, as soon you do R out GDAL, you create a location is duplicated. So both of them are fine. Something to see, I want to run one script also because I didn't show you how to do some operation. Okay. Okay, let me run directly the script that I have it for you guys. Flash project. Actually, I can take it from here. Okay, so if I want to run this script, it should run without problem. So now we run it, I can check, I can see what is running, okay, with the usual MyQ. And this is the name of the node. Be careful about you guys, especially more advanced people. You can enter in this node directly with SH, okay? Now you can see, you do yes. Now you can see, permission denied. Raymond, why get permission denied? The other day I could enter. I did, no? Oh, okay. To see what is going on in the node. S. Okay. Okay. Okay, because in other cluster we can. Okay, never mind. So srun, and then because if you are able in some, maybe if you have an HPC, some HPC allowed to SSH inside to the run, inside to the node. And then if you do just top or htop, you can see the grass, for example, running. And you can see GTAL translate 4 times. So it means that you are using 4 CPU. Okay, so it's very convenient to see really what you are doing. Okay, so but probably Raymond is going to let us know the tricks. Okay. This is a kind of backup to really understanding if your job is really running in multi-core. Okay. For example, where I work at Yale, we can do it. This kind of, but of course I can only see. I cannot do anything. Yeah. Okay. So anyone has curiosity to use Grass for sample computation?
Yeah.
Lucy, for sure. Maybe you can paste in Discord. I send you the link for Discord.
I'll try to give me a second. Which node did you want to see?
Okay, now it's already gone, but I can rerun. WNC15, CA15.
Which one?
WN, can you see?
CA15. Okay. Let's see. Is that node full? Check.
Main time. Anyone else is thinking to use Grass for some computation stuff? Not really? Okay. So we have only Lucy struggling with this. Okay.
So I will give you the commands.
SQ, like for MyQ let's look at the node numbers and then we jump into the node.
Yeah, but I can't, because for the configuration of the Slarm cluster we can't, but we can in the Yale cluster. So many clusters they allow where you have job running to enter and see what is going on. So you just do it SSH, and then you enter into the node, and then from the node you can do htop to see what you are doing, but here I can't. Okay, but if you...
So I gave you a command now on Discord.
Okay.
But it's, I think the node is full, so you can't access it if it's completely full. This was CA15, right?
Yeah, let's see if I can see.
CADC.
Ah, you are there. Ah, okay. Okay, let me try. Okay, so if I do my queue, okay, Control S batch. Okay, my queue again.
But the node is currently full, so the command won't work because there's you need one free CPU to log in. You have a node which is not full. For example, let's see, it's pretty full at the
I know, because
if you use the reservation, it'll probably be okay. But the cluster right now went almost completely full. So we have one user using 1400 cores at the moment.
okay, this one I can't see, for example. Because you won't let me in. Okay, get it. Why? Okay.
Try maybe one of the GPU nodes. Those might be empty.
Okay. Now I'm, for example, now you can see that I'm in.
Yeah.
Okay, but could be that my is done. And actually, if you do htop with user and you do your user, teacher, Joe course, blah, blah, user. Okay, so you should see over here the command that are running, but my Grass job is already over, so I can't see anything, but this is the way to do it, okay? Ah, right, yeah.
You always need one free core.
Ah, right, yeah. Okay, so the trick is that you need to pre-enter. 1 second, that I will explain this line. And then to exit, you just go exit. So this line is nothing else that let you in inside to the node using one CPU and be in the interactive mode inside to that node, and then you can monitoring. But this one need to be done in the same moment that your job is running. So especially if you have one job running for few minutes, it's easier to get in. Now, as soon as I get in, then the other job is gone. Okay.
And Giuseppe, we have one other thing. There is a Grafana dashboard where you can also monitor at the node level.
The which one? Sorry.
There's a Grafana dashboard at the node level where we can also monitor. So if we want, we can show the dashboards at some point. There are a variety of Grafana dashboards that show different things.
There is a web interface.
Yeah.
Okay, cool.
So, but that's maybe something for tomorrow.
Okay.
Because you also
Cool.
need your password from the email that you got for your
Okay.
account. So actually log into that. It's behind a password in order to see it.
Yeah, it's very important to check if you are really multi-core, okay? To see if your digital translate is 4 times, and because you can see really easily, okay? Okay. Any question concerning Grass session and so on? Okay, cool. So feel free to keep working with your stuff, and we will be around as usual.